Hey kids, Flexing Teacher Weber here. I hope everything is going well. We have been using the Pythagorean theorem for right triangles to find missing sides of right triangles, whether it's the leg of a triangle or the hypotenuse of a right triangle. What we're going to do for the next few days, and it's the last thing we'll do in this unit, is we're going to use the Pythagorean theorem to solve some problems. So what I've got here is a page of problems. And what I'm going to do is I'm going to do a few of the problems with you to show you how you might go about solving a problem using the Pythagorean theorem. The key thing here is you're going to have to be doing some drawing of diagrams. Drawing of diagrams will help you solve these problems quite well. So I'm only going to do 3 problems from this page. What I'm going to do first is I'm going to start off with problem number 3. So let's take a look at problem number 3. It says a 7-meter ladder is leaning against a wall of a building. The foot of the ladder is 2 meters from the base of the building. How far up the wall is the ladder? All right. So I'm going to flip back and forth here from this page to a page where I'm going to show some work. So I'm going to flip forward here, and I'm going to draw the ground because we need the ground to draw our building and ladder on. So here's the ground. And it says there's a building, so I'm going to draw a building. And I'll put some windows. And I'll put a door. Okay, and I think the problem says it's a 7-meter ladder is leaning against the wall of the building. So I'm going to draw the ladder leaning against the wall of the building. Whenever we draw a ladder or have a ladder, it's always sort of hitting at an angle like that. So there's my ladder right there. Okay, and it says that that's 7 meters. So that distance is 7 meters. It's a 7-meter ladder. And it says the foot of the ladder is 2 meters from the base of the building. So the foot means the bottom of the ladder, and the base means the bottom of the building. So we're talking about this distance right here. This is the foot of the ladder. This is the base of the building. So the foot of the ladder is 2 meters from the base of the building. So I'm going to add that measurement in, 2 meters. And then let's go back and see what the question says. The question says, how far up the wall is the top of the ladder? So we want to know, how far up the wall the top of the ladder is. So we want to know the distance from here up to here. We want to know how far up the wall the top of the ladder is. We don't know that, so I'm going to assign that X. Now what we have here, for the most part, is a right triangle, right? The right angle would be right here. There's the right angle. Now I'm sure there's a degree of error in this, right? The building might not be perfectly at a 90-degree angle with the ground, but for the most part it probably is. So there's our right triangle. Now what we have here is we know this leg, we don't know this leg, and we know the hypotenuse. And remember, it's the squares of the sum of the square of the legs equals the square of the hypotenuse. So to figure out the value of x using the Pythagorean theorem, we would do this. So the side we don't know, we called x, so let's call that x squared, plus the other leg squared, so 2 squared, equals 7 squared, equals the hypotenuse. And then x squared plus 4 equals 49. Now we want to get the x squared by itself, so we want the plus 4 to go away, so we'll minus 4, minus 4. And we get x squared equals 45. But we don't want to know the value of x squared, we want to know the value of x. So the way we do that is take the square root of both sides. The square root of x squared is x, and the square root of 45, because this is not a perfect square, is going to be approximately 6 7/10. And this is a distance, this is meters. Now, we should always check and see if our answer is reasonable. It's a 7-meter ladder, pretty tall ladder. And we're saying it's 6.7 meters up the side of the building. That does make sense because it shouldn't be higher than 7, right? Because if it was higher than 7, that's taller than the ladder. So that's a very reasonable answer, and that's how we use the Pythagorean theorem to solve that problem. Basically, you're drawing a diagram to see a right triangle in there. Let's do another problem. Okay, I'm going to skip back to the problem page. So this was problem number 3. So I'll put a 3 there. Oops. Now, let's go back to the page. The next problem we're going to do is problem number 4. So let's take a look. A ship left Shippagan, New Brunswick, and sailed east at 20 kilometers per hour for 2 hours, then south at 25 kilometers per hour for 1 hour. To the nearest tenth of a kilometer, how far was the ship from Shippagan? All right, let's go to some paper. This is problem number 4. Now this problem involves directions, so I'm going to make a little directional chart here, right? So never eat soggy wieners. All right, and we want to draw out the direction this ship is sailing in. So I'm going to go back here, and it says the ship left Shippagan, New Brunswick, and sailed east 20 kilometers per hour for 2 hours. That means in 1 hour it sailed 20 kilometers, in 2 hours it sailed 40 kilometers. So I'm going to go back to my diagram, and it sailed east 40 kilometers. So I'm going to say that right here is S for Shippagan, and it sailed east for 40 kilometers. So I'll put a little point, and the ship goes ding diddling 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 ding 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 diddling diddling stop. So the ship sailed 40 kilometers, and I'll label that 40. Let's see where it goes next. I'm going to flip back, and it says it sails south 25 kilometers for 1 hour. Okay, so south is going to be down and just 25 kilometers. So I'm going to draw a line a little shorter than the 40 kilometer per hour one. So here it goes. Ding diddling 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 stop. We'll say that's 25 kilometers. So here's the boat right now. Okay, that's where the boat is. Okay, I'm going to draw a little boat. Okay, there's its boat. There's the sail. That's where the boat is. Now let's see what the question asks. It says, to the nearest tenth of a kilometer, how far was the ship from Shippagan? So what we want to know is we want to know this distance. We want to know, here's the ship. We want to know how far away the ship is from Shippagan. So maybe I'll draw that in with a red line. Okay. And we will call that x, because that's the distance we want to know. Now, if you look at this, we have a right triangle. And let's find where the right angle is. The right angle is right there. So we know both legs in this one. We know this leg, we don't know, and we know this leg. We just don't know the hypotenuse. So if we're to use the Pythagorean theorem to solve this, we would say the hypotenuse squared, so x squared, equals 40 squared, one leg squared, plus 25 squared. and I work down the page and I solve this, x squared equals, okay, 40 times 40 is 1,600, plus 25 squared, 25 times 25 is 625. I'll add those up. X squared equals 2,225. Definitely going to be using a calculator to figure out the square root here. This is not a perfect square, so we're going to take the square root of both sides. And you're going to get x equals, or actually not equals, I always do this. It doesn't matter too much, it's approximately 47 and 2/10, and we're talking kilometers. Okay, now look back at your diagram and your numbers. Does it seem reasonable that this distance would be 47 and 2/10 kilometers? Remember, the hypotenuse should be the longest side, and that is. And that seems really reasonable based on the distances they traveled, that the ship would be 47 and 2/10 kilometers away from Shippagan. So that seems like a really reasonable answer to me, and I'm happy with it. That's two ways, that's two examples of problem solving using the Pythagorean theorem. I'm going to do one more example, make sure you watch it, where you solve a problem using the Pythagorean theorem. So watch for that video next. Flexing Teacher Weber, out.